Hi, this is the lab report number 5 for Introductory Physics 1 of Coursera. For this lab, I choose to make a model of the solar system in LAB5. The lab report outline will be as follows. First, the fundamental principles, that is Newton's second law and then gravitational force. After that, I will talk about the massa, initial position, and velocity vectors of the different bodies. Then the system modeling in the Python code. And finally, the results, I mean the model output. The fundamental principles used in this lab are Newton's second law, that is a secret of the universe and relates the rate of change of momentum with all the forces exerted by the environment to an object. And in the other hand, the gravitational force in a multiparticle system, where the force, the gravitational force on I by J is equal to this equation, and the net force on I is equal to the sum of all the J forces acting on E, on I, and the net force on I is equal of the rate of change of momentum of I. The data needed to modeling the system are the mass, the radius, the position and velocity vector for all the bodies in the solar system. With that, you can see the big difference in size and the even bigger difference in mass of the different bodies, and the huge size and the huge mass of the sun in the system. Here is the line of code that are the fundamental core of the program, and here is where I make all the calculations for all the interaction of all the bodies in the system. Well, here is the model running. Here you can see all the system. Here is Neptune, Uranus, Saturn, Jupiter, Mars, Earth, Venus, Mercury, and the Sun. Well, you can see that I try to put the orbit in with the 3 dimensions, and that is how it looks like. Well, the radius that I use to make the bodies are scaled in different way for the sun and for the planets. For the sun, I use a scale of 50 over the radius, but for the planet, I use a scale of 1,000 of the radius. One thing that I want to do with the model is to calculate all the forces over all the bodies. Here you can see all the forces exerted by the planets on the sun, and well, you can see that the very big force is on Jupiter. That's why if we make a zoom and we take out the scale, we can see that the sun is moving, and that's why all the orbits are moving too. Well, now I will run the model just for a year to see if the model can estimate the translation time of the Earth properly. And the rotation of the Earth, I use this line of code to make the object Earth rotate, and of course To see the rotation of the Earth, I use delta t as 3 hours. Okay, let's see the model. Here is the model. Here is the Earth that is rotating very, very fast. And, well, let's do this run a little faster. The yellow dot represents the initial point of the Earth. And, well, the estimation is close. In this graph, I present the forces of every planet exert on the Sun. And you can see in the top, the smooth line is the force exerted by Jupiter, and the other line is the net force. And you can see the different planets, how they exert a force, gravitational force on the Sun. In the other hand, you can see that the axis, the y-axis, is in logarithmic scale. In the same way, this is a graph with all the forces exerted on Jupiter, uh, mainly by the Sun, very, very powerful force, and the other planets in a very, in a scale very, very smaller. Um, well, you can see why, in particular in this graph, is very important the logarithmic scale. And the time scale, as the same in the other graphic, is 30 years. And last but not least, thank you very, very much to all the people who made this amazing course. I learned a lot. I enjoy so much to do the lab, to do the quizzes, the homework. Was a really amazing, amazing work of teacher, assistant, people of Coursera, the great artists who made such a beautiful videos, and my dear peers that helped me a lot with all the products. Thank you very much.